Welcome back. This is Advanced Geometry with Mrs. RRubright. Today's lesson is 11.7, Volume of Pyramids and Cones. Find the volume of the solid. Alright, so what is this, guys? Triangular pyramid. Good. The base names the shape. The base is a triangle, and a triangle has three sides, so there's three triangles coming up to the vertex up here. Perfect. Alright, so the volume of a pyramid is always 1/3 area of the base times the height, right? The volume of a pyramid is always 1/3 area of the base times the height. The base is a triangle, and the area of a triangle is 1/2 base times height. So 1/2 of that 4 times 6 times the height of the pyramid, the distance from the base, the perpendicular distance from the base to the vertex, and that's 9. 4 times 6, 24 divided by 2, 12. 12 divided by 3, 4. 4 times 9, 36. This can completely be on a non-calculator section. 36 meters squared. Oh, why did I say squared? Squared is what? Area. Area is 2-dimensional. Volume is 3-dimensional. Cubed. Just waking up this morning. All right, 36 meters cubed. Volume is always cubed. All right, so the volume of this. What is this? This is a cone, and a cone falls under that same formula for a pyramid. So it's going to be 1/3 area of the base times the height. The base of a cone is a circle, so that's going to be 1/3 pi r squared times the height of the cone, the perpendicular distance between the base and the vertex, 4.5. At this point, I can pick up my calculator. 2.2 squared times 4.5 divided by 3, and I got 7.26 pi. That's in terms of pi. If they wanted it completely done and estimated, so then times pi equals, and this is approximately 22.81. 22.81. This would be centimeters cubed. Sometimes your answers will be left in terms of pi, so it's good to know how to do that. All right. Originally, the pyramid had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side length of the square base. So they're telling us the base is a square, and they're telling us that this is a pyramid. So here's our square pyramid. The volume of a pyramid is always going to be 1/3 area of the base times the height. If the height is 144, and we're looking for the sides of the base, so say that they're x, they would both be x, right? Because it's what? It's a square, all equal sides. So that'd be x squared. So 1/3 x squared times x squared times 144 is going to equal 2,226,450. The first thing I can do is multiply by 3 on both sides. And then divide by 144 on both sides. So let's do that first. 2,226,450 times 3 equals, divided by 144 equals. At this point, all we have is that x squared equals 46,384.375. To solve for the squared, we take the square root. So right now we have 46,384.375 equals x squared. Opposite of squared is square root. Take the square root on both sides. And I get that x is approximately 215.37, and this is in meters. All right, so we're finding the side length, so it's just in meters. It's one-dimensional. There's our 215. Find the volume of the solid. Round your answer to 2 decimal places if necessary. So once again, it's a pyramid. Volume equals 1/3 area of the base times the height. All right, so this base has 1, 2, 3, 4, 5, 6 sides. It's a hexagon. Let's draw one of those 6 triangles. All right, so the triangular base is 4, so they're 2 and 2, right? What else do we know? We know that it's a hexagon, 2, 4, 6. So 360 divided by 6 is 60 degrees. So if this whole angle here is 60 degrees, then they're 30 each. So this is a nice little 30, 60, 90 triangle. X, 2x, x rad 3. So the area of the hexagon is 1/2 AP. 1/2 the apothem, or that height, of 2 rad 3 times the perimeter of the bases. Well, 4 times 6. 6, 6, 12, 12, 12, 24, right? 24. 4 times 6 is 24. So this is the area of the hexagonal base. So these 2's cancel out, and we would have 24 rad 3. So 1/3 area of the base, 24 rad 3, times my height of my object, which is 11. The height of the pyramid is 11. All right, so 24 divided by 3 is what? 8. So 8 rad 3 times 11 is 88 rad 3. So your exact answer is 88 rad 3. If I take 3 square root times 88 equals, I get 152.42. 152.42. Okay. What is the volume of the cone? Well, the volume of the cone is 1/3 area of the base times the height. 1/3 pi r squared, the base is a circle, times the height of the pyramid or the cone. 1/3 pi times 5 squared times the height. Oh, we don't have the height. We need to find it. We know that this is 8 and this is 5. We can use Pythagorean theorem to find the missing side, right? When you know 2 sides, you can find the third. A squared plus B squared equals C squared, right? So our height squared plus 5 squared equals the hypotenuse squared. So we're going to have 8 squared is 64 equals 25 plus that height squared minus 25 on both sides. H squared equals 14, 6, 5, 3, 39. Square root. So times the square root of 39. All right. So we would have 25 over 3. Oh, hold on. 25 pi rad 39 over 3. It's an ugly answer. Let's see what it is as decimal. 39 square root times 25 divided by 3 equals, times pi equals, I got 163.49. 163.49. The volume of a right cone. So the volume of a cone is always going to be 1/3 area of the base, pi r squared, times the height. 1350 pi equals 1/3 times pi r squared times the height we're looking for. All right, cancel out your pi's, right? If you divide by pi on both sides, it's gone. Multiply by 3 on both sides. The 3's gone. So 1350 times 3 is 4050 equals 18 squared h. Divide by 18 squared on both sides. and you have h. So 18 squared is 324. So I'm going to cancel this out and put 324. All right, so 4050 divided by 324 equals, I got 12.5. Your h is 12.5. Our units are meters, so our height is 12.5 meters. Find the volume of the right cone. All right, well, the volume equals 1/3 area of the base pi r squared times the height. 1/3 pi radius squared times the height of 16. All right, so what is our radius? Well, we have the 65 degrees. We have opposite. We need adjacent. Opposite and adjacent go with who? Opposite and adjacent go with who, guys? Tan. Tan of 65 equals opposite, that height, over, oh wait, that height has a number, doesn't it? That height is 16. Opposite, 16, over adjacent, r. Tan is opposite over adjacent. Okay, so times r on both sides. R tan 65 equals 16, right? Divide by tan 65 on both sides. And you get that r is 16 divided by tan 65. 16 divided by tan 65. All right, at this point we can use our calculator. 16 divided by 65 tan equals squared times 16 equals times pi divided by 3. And I got 932.68. And this was in feet, so it's feet cubed because volume is always cubed. 932.68. 932.68. They're going to finish it on the next page. So depending on what you use, it might be slightly off. So they prematurely rounded. You're not supposed to. That's what they did. They used 7.46 squared. You should never round until the very end. And that's why my answer and their answer is slightly off, because they rounded this prior to using it. They should have used the full number and squared it. Okay, so they're slightly off. So they would actually be wrong on the EOC. Find the volume of the solid shown. Okay, so the volume of this complex shape, or this composite solid, all you're going to do is you're going to do the volume of this. What is this shape right down here? It's a cube. The volume of the cube plus the volume of this, which is what? What kind of pyramid? A square pyramid. Okay. So we have to do them separate. So the volume of the cube, area of the base, 6 times 6, or 36, times the height, 36 times 6. What is 36 times 6? 216. So the volume of your cube is the area of the base times the height, or 36 times 6, okay? And now you have to add that to the volume of your pyramid. So the volume of the pyramid is 1/3 area of the base, 6 times 6, or 36, times the height of 6. 36 times 6 is 216. 216 divided by 3 is 72. And 72 plus 216 is 288. So the entire volume is 288 meters cubed. 288 meters cubed.